Hi boys and girls, today we're going to do the second method of factoring, which is how do we factor expressions using the greatest common factor. A greatest common factor is the largest number or term that divides evenly into two or more numbers or terms. So in this first example, I'm just asking you to find the GCF of two numbers, 24 and 36. So here I've listed for you all the factors of 24 and all the factors of 36. The largest one they have in common is 12, so therefore that's the GCF of 12. That you've seen in elementary school. But now when we see powers and we need to get the greatest common factor, I'm going to show you listing out the factors of x cubed and x to the fifth so we could find the GCF of x cubed and x to the fifth. Factors of x cubed are x, x squared, and x cubed. The factors of x to the fifth start at x and go all the way up to x to the fifth. So the largest one they have in common is actually the smaller exponent, x to the third power. So we keep the base x and we put the smaller exponent as the power. So now let's look at factoring using the GCF. We're going to take out the GCF of the terms and put it on the outside of the parentheses. That's going to be a single term for our first factor. We're going to get the second factor that's going to go inside the parentheses by dividing the terms by the GCF and putting what's left inside the parentheses. So here's our first example, 3x plus 9. What could we divide into both 3x and into 9? If you said 3, you're correct. So 3 is going to go outside the parentheses. I set up parentheses. Since there's two terms in the original polynomial, I know there's going to be two terms in the parentheses. And I'm going to get those terms by taking the original polynomial, 3x plus 9, and dividing it by 3. So I'm going to get x plus 3, and that goes inside the parentheses. So now you have two choices of how to check this. You could multiply and see that 3 times x would give you the 3x, 3 times 3 would give you 9, or you could put them into the calculator and see, just like yesterday's example, if I graph the original polynomial 3x plus 9, and then the factored form 3 parentheses x plus 3, yes, you could put those on. Then they will graph right on top of each other, and you see that they're equivalent expressions, just one's in factor form and one's not. The second example, we have 2x minus 2. So what could we divide into both 2x and 2? We could divide them both by, you said it, 2. So that's the first factor that goes outside the parentheses. Then I'm going to divide both of these terms by 2. And I'm going to get my second factor, which is x minus 2 divided by 2, 1. So I have my factored form 2 times x minus 1. If you multiply that, you would get back to the original 2x minus 2. Now I'm going to pause. This first video is going to stop. Do the classwork examples, and then I'll come back on with another video to go over those.